Hello everyone, I am Atharv Natu and I will be presenting my Windev 2024 image editor project entitled as PhotoMind. First, let's see the technology used in this project. PhotoMind is based on 5 things: Win32 SDK, which utilizes C and C++, COM, that is Component Object Model, CUDA, that is Compute Unified Device Architecture, OpenCV, which stands for Open Computer Vision, and Python. Let us explore the application now. After building and launching the application, we see the user registration dialog. Here, we have to enter the first name, middle name, and the last name of the user to register. The data entered by the user will be spot validated. That means, on entering the text input, if the user enters numbers or special characters in the text field, that particular text block will be highlighted to prompt the user to enter correct data. After registration, we will click on the File menu and select Open to open an image file using the File Explorer. PhotoMind is GPU accelerated, so when an image with large number of pixels and a relatively larger size is loaded, all operations are performed seamlessly on the GPU. Otherwise, the application will default to using the CPU. We can load image files with all major supported extensions like PNG, JPG, BMP, and WebP. The image information is displayed at the bottom of the window, and it includes the image resolution in pixels as well as the image size. On selecting Edit option from the menu bar, we will open the Edit dialog box. It contains options to select between multiple effects as well as a color picker section. First, we will apply the desaturation effect. As you can see here, the image got converted to a grayscale image. To reset the currently applied filter, we will click on the Reset Image button. Now, we will apply other effects like Sepia, color inversion, image pixelation, and blur, which utilizes the Gaussian blur equation. Moving on to the color picker section, as you can see, we have the color picker icon cursor to select any pixel from the image area. The square box displays the picked color, and besides it, the RGB values are also displayed. Along with this, we have 3 checkboxes which allow us to export or copy the picked colors. Picked colors will be exported to log files in 2 formats within a scale of 0 to 255 and a normalized format which ranges from a scale of 0 to 1. The third option allows us to copy the RGB values to system clipboard. As you can see here, we see the clipboard data being copied. On clicking the About button, we can see the About dialog, which provides information about the developer and the software version. Next menu option is System Details, which gives detailed information about OS version and the underlying hardware. Here, we can see the Windows 11 edition as well as the version. Then we can see the CPU generation along with the number of cores and the number of threads. Next, we have listed the amount of RAM installed in the system. The section below this contains information about the GPU vendor, model, and the video memory, that is the VRAM. Along with this, we can see the HPP platform that is being used currently to provide GPU acceleration. This information is extracted using WQL, that is WMI query language, where WMI stands for Windows Management Infrastructure. And now, moving on to the last menu option, we can generate AI images using text-to-image conversion. The model used for this is called as Stable Diffusion, which is provided by Hugging Face, a portal for AI models. The user has to enter a text prompt to generate an image. Here, we will enter a demonstrative prompt and set the image path to save the image. It takes a considerable time to generate the image, which is dependent on the GPU your system has. Now you can see the results which show the compute device used, CUDA in our case, the amount of VRAM and the actual time required for computation. We can verify the image generation by loading it. After exiting the application, we can see the log files generated. First is the user log file, where we can see the user details as well as the actions performed by the user. Then, there are two color log files which show the picked color values as well as their timestamps. So, to summarize, we will now see a list of features implemented in PhotoMind. Win32, which is used for native windowing, UI-related tasks, and multithreading. OpenCV, which is used for image loading of different extensions like PNG, JPG, BMP, and webp. CUDA for GPU-accelerated processing. COM, which is implemented through automation, aggregation, and WQL. Python COM Exe Server for stable diffusion AI model inference. C++ COM automation client. Image effects like desaturation, sepia, color inversion, pixelation, and Gaussian blur, as well as copy to clipboard functionality. Thank you everyone for exploring PhotoMind with me.